So from this chapter, we are going to discuss the remaining polynuclear hydrocarbon compound, that is diphenylmethane. So look into this structure. This structure will possess two benzyl rings. We can also call it as two phenyl rings, which will be breached, ज्या की ब्रीच केलेल्या आहेत मिथाइल ग्रुपने. So या दोन रिंगचं ब्रिजिंग किंवा या दोन रिंगचं जॉइनिंग will be done by this methyl bridge. So this compound is named as and nominated as biphenylmethane, ज्यालाच आपण काय म्हणू शकतो, diphenylmethane. So we are going to, if we are going to start the numbering of this compound, so we can do the numbering in this way, as these two rings are same. So according to IUPAC nomenclature system, we can nominate this as a 1 1 dash 2 2 dash, and these are the positions of this ring, that is ortho position, meta positions, and para positions. So these are the ortho dash, meta dash positions, and para dash positions. So this compound is also coming under the category of diphenylmethane. Now, about this compound, we are going to discuss the synthetic methods as like that of earlier polynuclear hydrocarbons. So some related compounds of diphenylmethanes we have already discussed, like phenanthrene, anthracene, and naphthalene. So naphthalene मध्ये काय आहे? These two benzene rings are breached with each other, with condensed with each other without bridge. There is no any presence of this bridging compound. या दोन rings as it is एकमेकांना attach झालेले आहेत. In case of naphthalene, in case of phenanthrene, and in case of anthracene मध्ये त्या linear manner ने attach झालेले आहेत, आणि phenanthrene मध्ये त्या angular position मध्ये attach झालेले आहेत. So these similar compounds we have already discussed. Now related to this diphenylmethane, what we are going to discuss actually, synthetic methods. So first synthetic method for this diphenylmethane is by Friedel-Crafts condensation. So what is this Friedel-Crafts condensation? This condensation is between the benzyl chloride and benzene. So if we are going to condense benzyl chloride with benzene in the presence of a condensing agent, that is aluminum chloride, this breached compound or this diphenylmethane will be produced by releasing hydrochloric acid. Now the yield of this compound or the synthetic synthesis of this compound, we can obtain 50% of the compound. म्हणजे if we are going to take this mixture of this compound, the production yield किंवा product ची जी काही yield आपल्याला achieve होणार आहे, it is about 50%. Low yield will be produced. Now, second synthetic method for the formation of diphenylmethane is by condensation between one molecule of formaldehyde and two molecules of benzene. See, the first synthetic method is by benzyl chloride and benzene. So this benzyl chloride जी काही methyl bridge आहे, this will be bridged between the two benzyl rings. Second synthetic method for the formation of diphenylmethane is by utilizing or by using two benzene molecules will be condensed with formaldehyde. Now this formaldehyde will be act as a bridging compound, will be act as a bridging methyl ring, and these two benzene rings will be condensed together. This will be the second synthetic method in the presence of concentrated sulfuric acid. So water will be released and there is formation of diphenylmethane. Third synthetic method for the formation of diphenylmethane by heating benzophenone with hydroiodic acid and in the presence of red phosphorus at high degree temperature, that is at 160 degree under pressure. So we require high pressure and high temperature for this particular reaction. But see the difference in case of first synthetic method, product yield किती आहे 50%. But if we are going to use a concentrated acid, then a red phosphorus and higher temperature and higher pressure, we can increase the yield of the product, that is by utilizing high heat and high pressure. Now the fourth synthetic method by allowing a mixture of benzyl alcohol and benzene, acetic acid, sulfuric acid to stand for 6 hours. So if we are going to allow the mixture of benzyl alcohol, benzene, acetic acid and sulfuric acid will be mixed together, and if we are going to allow them for 6 hours, this mixture will be results into the formation of diphenylmethane. But neither we have utilized any condensing agent, neither we have used any high pressure and high heat. The yield of this product is to minimum, that is 25%. Now, the last and fifth method for the formation of diphenylmethane is by reducing benzophenone with a mixture of lithium aluminum hydride and aluminum chloride. So what will be the reaction if we are utilizing lithium aluminum hydride so if we are utilizing by reducing benzophenone with a mixture of lithium aluminum hydride and aluminum chloride. Now, diphenylmethane, it is an crystalline compound and having one melting point, having too much low melting point, that is 26 degrees centigrade. Now, the reactions of diphenylmethane are similar to those with an other polynuclear hydrocarbon. That is, nitration. On nitration, they are going to produce nitro compound will be enters at the fourth position, that is para position. If we are going to again nitrate this compound, the second nitration compound or the second nitro group will be occupied, will be attached at the second ring 4' position. See, the first nitration is done at the first ring para position. Second, आणि आपण further जर nitration केलं, then the nitration will be done at the 4' position. Because the benzyl groups are what type of reacting? We know the benzene ring and their derivative in that topic we have discussed. The nitro groups will generally oriented at ortho and para oriented. So these nitro groups are occupied the positions, that is para positions. Since the hydrogen of the methylene group is very active, the hydrogen which is there as the methylene group in case of bridge between the two benzene ring, this hydrogen is very reacting. What is the reason behind that hydrogen is reacting? Due to each ring being electron attracting. See, phenyl ring आहे, so ती ring काय करते? They are going to attract those electrons, and त्या ring ने electron attract केल्यामुळे these rings are behaves as a negative group, and these rings are behaves as a negative group. That's why this methylene bridge will be behaves as a positive group. त्यामुळे त्याचा जो काही हायड्रोजन आहे त्या मिथिलीन ब्रिजचा, इट इज व्हेरी ऍक्टिव्ह. The bromination of diphenylmethane gives rise to substitution at methylene carbon atom. म्हणूनच सी those two lateral benzene ring किंवा terminal benzene rings आहेत त्या निगेटिव्ह ग्रुप म्हणून ऍक्ट होतात, आणि जो ब्रिज मधला हा जो काही सॉरी this bridged methylene group will be act as a positive group. म्हणूनच these two hydrogens of this bridged methyl group are very reactive. Now, as these hydrogens are very reactive and these two parallel or lateral benzene rings are behaves as a negative group, the nucleophile enters or the addition of this nucleophilic agent will be done at what position? The position of that methyl functional group. लक्षात येते? या दोन बेन्झीन रिंग्स लॅटरल पोझिशन्सला असल्यामुळे आणि त्या बोथ ऑफ देम आर इलेक्ट्रॉन अट्रॅक्टिव्ह टू अचीव देअर ऑब्जेक्ट.
हो सर एकच ऑटो काहीतरी आम्हाला
As these benzene rings are behaves as a negative radical, negative group, and the methyl bridge will be act as a positive group. That's why these hydrogens are very reactive. As these hydrogens are very reactive towards what type of reactions? Nucleophilic substitution reactions. So that's why this nucleophile, that is bromine, will be act at the what position? That methyl bridge carbon atom, and there is formation of this diphenyl methyl bromide will be formed. Now, generally, see earlier reaction, the nitration will be taken place at the para position, but bromination will be taken place at the position of the bridged methyl functional group. Now, this will be the bromination reaction. Now, when oxidized with chromic acid, whenever we are going to oxidize this diphenyl methane in the presence of chromic acid, diphenyl methane forms benzophenone. So, whenever we are going to oxidize this compound with the help of oxidizing agent, that is chromic acid, so there is formation of benzophenone, and when its vapors are passed through red hot tube, a very hot tube, diphenyl methane forms an fluorine. So this is an additive reaction towards the diphenyl methane. When we are going to oxidize this diphenyl methane in the presence of strong oxidizing agent, that is chromic acid, they are going to synthesize benzophenone. So this is with respect to diphenyl methane. Now our last and next polynuclear hydrocarbon is triphenyl methane. So it is prepared by, now the what we are going to discuss about this compound, that is synthetic methods reaction of triphenyl methane. So what is triphenyl methane? It is prepared by Friedel-Crafts condensation between benzene and either benzylidene chloride or chloroform. So whenever we are going to condense benzene with benzylidene chloride, in the presence of aluminum chloride, we can obtain a triphenyl methane. See, in case of diphenyl methane, this CH is CH2. But here we have substituted three positions of the breached carbon atom with three benzene rings. That's why the name of the compound is triphenyl methane. And there is formation of hydrochloric acid. So this method we have already utilized for the formation of diphenyl methane. Same method is there, but three benzene rings, that is triphenyl methane. Now, second synthetic method, we can also condense three benzene rings in the presence of chloroform and aluminum chloride. So there will be condensation between the three benzene rings, and there is formation of triphenyl methane. But the yield of the compound is very low because we have utilized an organic solvent. It is also prepared by condensing benzaldehyde with benzene. We can also synthesize triphenyl methane with utilizing benzaldehyde and benzene in the presence of zinc chloride. So we can condense both of them compounds to synthesize triphenyl methane. Now, triphenyl methane is colorless crystalline solid having a melting point 93 degrees centigrade. See, in case of diphenyl methane, the melting point is 26 degrees centigrade, but the melting point of triphenyl methane is 93 degrees centigrade. It is parent substance of the triphenyl methane dyes. So these type of compounds are generally used as a dye, coloring agent. When brominated, it forms triphenyl methyl bromide. See, the reactions of diphenyl methane and triphenyl methane are quite similar. The bromination is taken place at the breached carbon atom. Oxidation of chromium trioxide in the acetic acid. Now, whenever we are going to oxidize this triphenyl methane in the presence of chromium trioxide, this triphenyl methane will be converted into triphenyl carbinol. So, whenever we are oxidizing this triphenyl methane in the presence of oxidizing agent, and that is chromium trioxide, there is formation of triphenyl carbinol. Now, this compound may also be prepared by reaction between phenyl magnesium bromide and benzophenol. So, this triphenyl carbinol will be synthesized by utilizing benzophenone or ethyl benzoate. Now, what type of reactions they may ask, or what type of questions they may ask? They may ask, write the derivatives of triphenyl methane. This question is asked 2 times. So, what is the derivative of triphenyl methane? Triphenyl methane carbinol is the derivative of triphenyl methane. आणि ती कशी सिंथेसाइज केलेली आहे लक्षात येते. सो जर आपण ट्रायफिनाइल मिथेनचं ऑक्सिडेशन केलं इन द प्रेझन्स ऑफ क्रोमियम ट्रायऑक्साइड, वी कॅन सिंथेसाइज ट्रायफिनॉल कार्बिनॉल, की ज्याची एल्ड किती आहे 85%. आणि हा सेम डेरिव्हेटिव्ह जर आपण वेगळ्या 2 पद्धतीने बनवला तर दिस इज अन डेरिव्हेटिव्ह ऑफ ट्रायफिनाइल मिथेन. याच्यावरती क्वेश्चन विचारलेला आहे, लक्षात येतं. हा आपल्याला जर ट्रायफिनाइल मिथेनचा डेरिव्हेटिव्ह बनवायचा असेल तर काय रिएक्शन आहे? दिस कंपाउंड मे also be prepared by reaction between phenyl magnesium bromide and benzophenone. So phenyl magnesium bromide, that is Grignard reagent. Magnesium bromide will react with the benzophenone, condensation, intermediate product of Grignard reagent, and after the removal of water molecule they are going to synthesize triphenyl carbinol derivative having an yield up to 75%. Same compound, that is triphenyl methyl carbinol आपल्याला synthesize करायचं असेल तर second method, that is ethyl benzoate reacts with the Grignard reagent, but we are going to utilize 2 molecules of Grignard reagent to synthesize intermediate product, and again with the removal of water molecule they are going to synthesize triphenyl methyl carbinol having an yield 89 to 93%. So असाही क्वेश्चन विचारला जाईल की whenever we are going to